Okay, this is going to be a test run of how we're going to be correcting homework for distance learning. So somebody posted last night or tonight, question number 7, and I believe this is from exercise 4.3 in the new Ibid. And the question asks us to use the first 4 terms of the Taylor polynomial to approximate the definite integral of arctan square root x between 0 and 1. So in order to answer this question, the first thing we need to know or remember is that the arctan x has a Maclaurin series expansion that looks something like x minus x cubed over 3 plus x to the 5 over 5 minus x to the 7 over 7. Okay, the general term is x to the 2n plus 1 over 2n plus 1 minus 1 to the power of n would start off negative. We want to start off positive, so n plus 1 will work for us. This formula is on the formula sheet or in the data booklet, but I believe it only has the first 3 terms. So only this portion here, you'd have to figure out what the 4th one is if they want the first 4 terms. Okay, how is this going to help us answer the problem? Well, we can use this to determine the arctan of the square root of x by simply making a composite function. So this is the square root of x minus square root of x cubed over 3 plus the square root of x to the 5th over 5 minus the square root of x to the power of 7 over 7. And those are the first 4 terms of the arctan of the square root of x. So we simply just substitute the square root of x in where we see the x. Now we see the question's asking us to evaluate a definite integral. So we're going to take the definite integral of arctan root x, which means we're just going to integrate the function that we just determined. In order to integrate that, it might be easier to write it in exponential form. So it's square root of x is x to the 1/2, and then we have 1/3 times x to the 3/2, and then the next term is x to the 5/2. I'm just going to put it over 5, and the last one, which is minus, will be to the 7/2 over 7. And we want to integrate that term by term. So the theorem says that if the Maclaurin series is convergent on a interval I, then the integral of the Maclaurin series will also be convergent, and that interval is found by integrating each of the terms of the Maclaurin series term by term. So this will be x to the 3/2, and then we'll multiply by 2/3 because we're dividing by 3/2. This one will add 1 to the exponent again and multiply by its reciprocal. And I'll just put the 1/3 underneath x to the 5/2, and then we have x to the 7/2, 2 over 7 times 5, and then the last term here is x to the 9/2, 2 over 9 divided by 7. And those are the first 4 terms that we're going to use to determine the definite integral. And since it's a definite integral, we have to sub in the limits of integration, the 1 and the 0, and then take the difference. So this leaves us with 2/3. Now it's 1 to the 3/2, which will be 1. Each one of these x's, here, 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 and here, will receive, we'll substitute x in for those, and so we know they're all going to be 1. So 2 over 5 times a third, 2 over 7 times a fifth, and 2 over 9 times a seventh. because whenever you put 1 to any power, you get 1. And then we would have to, that would go on forever, and then we would have to subtract from that the value if you sub in 0, where you've highlighted all those x's. Well, of course, that'll just give us 0 minus 0 plus 0, in other words, 0. So in fact, then, we can approximate this definite integral by the 4 fractions we've listed above. So 2/3 plus 2 over 15 plus 2 over 35 minus 2 over 63. And we'll put a squiggly equal sign there to say we're approximating it. Now, in order to figure out what that is as a decimal, we'll just use our calculator. I'll have to turn mine on here. Let's see, it's been turned off. Okay, and let's put that over here on the side of the screen. And we'll clear all that out. So if there's 2 divided by 3, I see I made a little error here. This should be minus, because we're alternating signs. So minus 2 divided by 15 plus 2 divided by 35 minus 2 divided by 63, which gives us an approximate value of about 0.55830. So we'll put another approximately equal sign. So to 3 significant figures, the answer is 0.559.